So in video 3, we're going to use the key features of a quadratic function to graph it. So we're going to find the x and the y-intercepts, the vertex, and the axis of symmetry, and use those as graphing tools. So here we're given a function f of x equals negative 1/2 x squared plus 2x plus 3. We need to find each of its key features in order to graph those and then draw the graph of the function by using those key features. So first I'm going to go hunting for the axis of symmetry. And as we've already seen in a previous video, the axis of symmetry is given by x equals the opposite of b over 2a from the front part of the quadratic formula. So we look up at the quadratic function we see that a is negative 1/2. And we see that b is just equal to 2. So we'll replace the b and the a with those numbers. So we get the opposite of 2 over 2 times a, but a is negative 1/2. And 2 divided by 2 will equal 1. So we're going to get negative 2 over 1 times negative 1 is negative 1, and this is just going to equal 2. So the axis of symmetry is given by the equation x equals 2. So I can come up here and I can graph the axis of symmetry for the quadratic function. Once I found that axis of symmetry, I can use that to find the vertex, because we know that the vertex is found by inputting the x-coordinate of the axis of symmetry into the function. So we evaluate f of 2, which is going to equal negative 1/2 times x squared plus 2 times x plus 3 from our function up here. And so everywhere there was an x, we are going to replace that x with a 2. And then we'll simplify. We get 2 squared is 4. 4 divided by 2 is 2. 2 times negative 1 is negative 2. Plus 2 times 2 is 4. Plus 3. So negative 2 plus 4 is 2. Plus 3 is 5. So the vertex, again we're finding the vertex here. I should explicitly say that. The vertex is an ordered pair, so we input 2, we output 5, and that gives us the vertex. So input 2, output 5, there's the vertex at 2, 5. Now I'm going to find the y-intercept, or the f of x intercept, and we want to recall that when we find the vertical intercept, the x-coordinate is always 0, so we just need to put 0 in for x. So we can step down here and we are going hunting for the f of x intercept. And we get that by inputting 0 for x, so we get negative 1/2 x squared plus 2 times x plus 3, but everywhere there was an x, we replaced that x with a 0. So we're going to get 0 plus 3, which is just 3. And again, the intercept is a location, so it is an ordered pair. Input 0, output 3, input 0, output 3. There's the vertical intercept. Now, here's the axis of symmetry, so there should be a point that is that corresponds to the point 0,3 reflected in the axis of symmetry. So this is 2 units away from the axis of symmetry. So over here, 2 units away from the axis of symmetry, we get the point 4, 3. Each point located the same distance from the axis of symmetry. Each point is a reflection of the other in that line. So the other 2 key points we need to find are the x-intercepts, the places where the function crosses the x-axis. And what we want to remember is that as we cross the x-axis, the y value, or f of x value, is 0. So if we're going hunting for the x-intercepts, the places where we cross the x-axis, we're just going to take our function and we're going to set our function equal to 0. We're going to identify the values of x that generate outputs of 0. I'm going to use completing the square as my technique. You could use the quadratic formula just as easily. To complete the square, we need to remember that we need a leading coefficient of 1 on the x squared term. So I'm going to multiply by -2 because -2 times -1/2 is 1. So I'm going to multiply all of the left-hand side by -2, and I'm going to multiply also all of the right-hand side by -2. So 0 times -2, that's the hard one. -2 times -1/2 is 1 x squared. -2 times +2 is minus 4 x's. -2 times +3 is a minus 6. And then I'm going to take and add 6 to both sides to get the x terms by themselves. We then want to take half of the linear coefficient, half of the -4. Let's find a space here to do it where I don't run into where's my face at? Somewhere in here. So we'll take half of the -4, that's the linear coefficient. We're going to square it. -4 divided by 2 is -2. We're going to be squaring a -2, which is going to give us a 4. So we're going to add this 4 to both sides to complete the square. 6 and 4 gives us a 10. And then I completed the square. So what square did I complete? I completed the square given by x. And what number got squared? -2. And then I'm going to get rid of this work so that I have a little more space on my slide. And now I'm going to use the square root property. I'm going to take the square root of both sides. The square root will cancel the 2. Take the square root of this side. And then I need to take the square root of this side as well. But when I take the square root of the right hand side, I'm going to get a plus or minus the square root of 10. The square root will cancel the squaring, leaving me with x minus 2. And then we'll add 2 to both sides. Get 2 plus or minus the square root of 10. If I get decimal approximations, which I usually don't do, but in this case we want a graph, so it'd be nice to have decimal approximations. Turns out that 2 minus the square root of 10 is about -1.16. And 2 plus the square root of 10 is about 5.16. So this really generates two ordered pairs. The intercepts are at -1.16 comma output 0 and input 5.16 output 0. And then I'm going to graph those 2 points. So -1.16 is going to be about here. That's -1.16 comma 0. And then 5.16 will be about right here. 5.16 comma 0. And now we've got enough points to draw the graph using all the key features. So draw the parabola opening downwards. We know it's opening downwards because that negative sign has reflected x squared, the toolbox function, over the x-axis. So we have an x-axis reflection that we see happening because of the negative. And now I draw the other half of the parabola opening downwards. Ooh, I think that's my best one I've drawn. I'm so pleased. Anyways, there's our function f of x, drawn using the key features of the graph.